All right, welcome back once again, everybody. It's the Dr. Tree Fruit and Don podcast. We are doing our post-harvest rot series. We're here with Dr. Kari Peter. Say hi, Kari.
Hello.
And Dr. Wayne Jurick joins us once again. Say hi, Wayne.
Hello.
So, Wayne, you are the star of the show this week. Thanks for joining us with Johanny and having the folks in your lab participate in this. You know, folks will hear that as episodes are released. But Wayne, why don't you start by kind of giving us an overview of what your lab's about, what work you guys are doing, you know, how long you've been with USDA, that sort of thing.
Sure. Yeah. Thanks. I appreciate the invitation and the opportunity to talk about the program. Yeah. So I'm originally from Florida. I'm native. I came up here on a postdoc working for Bill Conway. 2008. I've been at ARS for 15 years now. And Kari was my first postdoc way back. And so basically the focus of the program has always been on controlling post-harvest rots of home fruit, primarily apple, but some pear and a little bit of stone fruit, peach, and some small fruit work in the beginning, strawberry and blackberry, raspberry. So the program is broad. We do a lot of work on basic science, fundamental science, but also applied, the things that can be used relatively soon to deliver to growers. Kari and I work quite closely together on projects of post-harvest interest. So the program is broad. It mainly focuses on fungi, post-harvest diseases of apples, stored fruit, mainly blue mold, gray mold, some Calototricum. Those are the diseases we focus on.
So your lab, you described it as a post-harvest lab, mostly on tree fruit, right? You said mostly pome fruit, but also doing some of the stone fruits as well. How many folks are in the lab with you? It's yourself and how many others?
Correct. So right now it's me, my support scientist, Miss Vernetta Gaskins, and I have been working together for the entire time I've been here, 15 years. Then we have two postdoctoral scholars, Dr. Dianitas Luciano Rosario from Wisconsin, just graduated from the University of Wisconsin. And I have Dr. Holly Bartholomew, who came from Virginia Tech. She's been with me closing in on 3 years now. So I think that's it at this point. 4 people, including myself.
That's interesting. I think when most folks think of probably like a USDA lab, you know, a big government lab, they think like huge. They're probably thinking you're in charge of 50, 100 people plus people. But the 4 of you doing that much work is really impressive, actually.
Thank you. It's a small but mighty functional unit. And what I found is I'm not against having many people. I like to mentor. I've had high school students. I've had postdocs. I've mentored lots of people. But what I find is you don't need a whole lot of intellectual mass to be able to get a lot done. And so if you're efficient, you can really make some impact. I've just preferred it that way. And in the past, I think I've had maybe as many as 6 people in the lab at one time. But I hover around 2 to 3. And I've had people from all over the world. I mean, China, Puerto Rico, of course, a lot of people stateside. So I enjoy that. It adds a cultural diversity aspect to the lab. And also from an intellectual perspective, it's good to have different viewpoints. People coming from different backgrounds. For example, Kari came from a virology background, and she came to my lab working in the fungal world. She had a different perspective, which was good. And, you know, it's nice because it makes you better and it strengthens the mission.
Yeah, that's really cool. Like I said, I think most folks, when they think of like a government lab, a USDA lab, they're probably thinking a ton of folks, but anywhere between 2 to 6 that's a pretty tight crew. Give folks a little bit of information, a little bit of background on how you go about doing your day-to-day work, you know, how you study what you study, what kind of a day in the life of USDA pathologist looks like.
Sure. Well, the fun part about that is there's really no single day that's the same. So it could be something as simple as just hosting people from industry in my lab, or attending a lot of the ARS mandated meetings, or having these Zoom meetings with Kari and Johanny to understand what's going on with our project. From a research perspective, I still do work in the lab. I like to work in the lab, but I found myself spending an inordinate amount of time on the administrative affairs, and that's okay. I think that's where I'm at in my career path right now. But for example, somebody brought me some symptomatic fruit from a commercial grower and also from a research orchard. And so they wanted to know what they had. So I had to get in there and isolate and diagnose and figure out what this was. So that was something that got dropped off to me one day, and that was kind of fun. So I got back into that aspect. But a lot of it's time in my head and in discussions. So we use a lot of the same technologies that are used in cancer and human disease biology, try to understand how fungi, particularly blue mold, gray mold, how they cause disease and what tools they're using, and also how these toxins they're producing influence this interaction. And what we want to do, our long-term goal, is to be able to uncover the Achilles heels, if you will, of the pathogens. The pathogens, the fungi themselves are very smart, they're very sophisticated, and they use a lot of different things to incite decay. And if we can understand some of these processes at a fundamental level, the goal would be to develop an array of, say, cultural, chemical, and biological means to interfere with those processes to ensure food safety, quality, and to reduce food loss and waste. That, I would say, is our sort of our main goal, and from a global perspective. And from a micro perspective, the lab work is, again, spans the gamut from fundamental to applied. We do work with fungicide resistance, virulence mechanisms, toxin biology. I think those are the three main fronts at this point.
When you talk about some of that practical research, how much of that are you guys developing in-house? If you're looking at fungicide resistance for blue mold, you guys aren't coming up with those chemistries, are you? You are just utilizing things that are already available?
Correct. With the fungicide resistance project, we're not developing new chemistries. The hope is we can identify processes and pathways so that new targets can be identified that gives the chemical companies or researchers like myself an inroad to developing a new chemistry, maybe. That's one option. But no, we ourselves are not developing new chemistries. We're trying to provide the information in which this can be achieved. So for more of the practical work, we've focused really mainly now on the bin project with Kari and Carrot Cox at Cornell University. I can tell you a little bit about that project if you think that'd be interesting for your user base.
I know we'll have an episode with Deaneris on talking about her work with the bin stuff, but if you want to give a brief overview, that's cool for a little teaser.
Yeah, I have a habit of sometimes stealing people's thunder. I don't want to do that to her, but in a nutshell, we compared plastic versus wooden bins and their ability to harbor fungal spores. And also we looked at a couple of benchmarks for sanitizing or killing the spores. And the short story of what we've done is that the plastic bins hold less spores than the plastic bins hold less spores than the wooden bins, and that the steam or hot water treatments coupled with chemical treatments can really help knock down the levels of blue mold on the bin surfaces. And that's where I'll leave it at that. And then I'll let Deaneris take it from there. But it's exciting. It's good. We have a long way to go, but I think we have some good information to build upon.
So one thing, you had alluded to, collaborations. And I think for those, for folks who either are new to the podcast or aren't familiar as far as how we kind of divide and conquer with regards to research projects or research questions. So, I cut my teeth on tree fruit working in Wayne's lab. And again, it's like it opened up this whole new world, and I never looked back. But what's exciting is that in my position at Penn State, I have a very applied focus. And by working with Wayne, we're able to expand that focus to look at more basic questions and more fundamental questions, which is really great. So we can kind of be able to sort of get the best of both worlds based on our specialties. And, to the point where Wayne is on my student Johanny Castro's PhD committee. And so, which is really exciting to be able to have that expertise, a part of the program, albeit tangentially, but it's critical nonetheless. And I think that's what's exciting, especially from the academic side at Penn State, being able to connect with the USDA and the federal government to be able to really forward the mission as far as what we're trying to do. And that's to minimize, as Wayne alluded to, minimize food waste and reduce fruit rots and stuff. So I think I just wanted to give a shout out to that because I've really appreciated the collaboration and being able to continue. And I will say, between Johanni's interests in post-harvest diseases and being able to maintain the collaboration with Wayne post my time at the USDA has been great, because this has been a whole huge niche for the Mid-Atlantic that has not been, has been kind of neglected over the years. And so it's good to be able to sort of join forces to basically to get a lot of research done in a short period of time.
That's really cool. One thing that I just want to circle back to for folks that maybe don't have like a scientific background, Wayne, you and Kari have said basic research and fundamental research. Could you just give a brief explanation of what that means?
So Kari, do you want me to answer that, or do you want to take a stab at it, or?
Okay, well, I'll take a stab at it, and then
Sure.
you pick up where I left off. So
Sure.
let's see if I can explain it. So, well, first, I mentioned I do applied research, which a lot of that deals with going out into the field, like testing a research question, whether that's a product or finding a spore source or testing some sort of mitigation measure that ultimately will lead to a tool that will be put into the hands of growers immediately. I guess that's the way I've always seen as applied research. It's the research I do is applicable on the bigger scale. Basic research or fundamental research is, I guess, the way I've always viewed it is it's really getting into the nitty-gritty of stuff. It's getting to the foundation of trying to understand sort of the core of the question. So, like, for instance, I'll just use fungicide resistance as an example. Okay, if we know something is fungicide resistance, yeah, that's all well and good, but why? How is the fungus able to withstand the ability of being in the presence of a fungicide? And to investigate that, you would want to look at, well, does it pump out the fungicide? Does it have genes that are changed in its sequence that allows it to be in the presence of fungicide? Is there another mechanism that it's able to somehow detox itself? So, it's more of on a biochemical, using biochemistry tools, molecular tools, using microscopic tools as far as being able to answer that question. So I see almost applied research on the macro level, being able to take a tool and apply it. And then the fundamental or basic research is really getting down to the nitty-gritty micro or molecular level. But please, Wayne, pick up where I left off as far as giving more details of that. But I appreciate Don's question, because that's an important question.
Yeah, I agree. I think you did fine. And I think much like our research program, you covered most of it, and then we can synergize the answer. How's that? I think you have exactly right with the applied and the basic. I think sometimes people use basic science and fundamental science as sort of synonyms. So I think you can consider those two in the same group, and they're exactly that. They're the why. So you have basic / fundamental research is the why, the nitty gritty, and that oftentimes can or should drive the applied, but the applied can also drive the basic, right? Just like what you said. And to sort of take it a step further, I think the only other term that we've used in the past is the translational. So once you take the fundamental research and move it to the applied, you can translate that to something, for example, your fungicide resistance work, our work. So maybe if we understand how the fungus is doing what it's doing with a pump, maybe we can inhibit that pump with a product that exists or develop a new product so that then we can regain control of those isolates that are no longer sensitive to the fungicide. We can make them sensitive again. So that's an example of translational science. And I think that covers the entire definition of what we do together and what we can accomplish individually and then synergistically to serve the research mission of the growers. And that pretty much covers it, I think.
Awesome. Thank you guys for that definition, because I know we threw around basic and fundamental. I know what you guys are talking about, but I know that basic can very easily be translated as easy, right? It's like you can make those synonyms connect. And if you don't understand that they have a very specific definition with what we're talking about, I feel like folks could get lost in the weeds there.
Yeah, that was a great question to ask. And I also say is that as scientists, we can have a foot in all the different worlds. You don't have to be exclusive in one world. And all of my training, as far as my graduate training, really could have been considered, I was in basic research. And so I personally like it. I like being able to have that flexibility. But we're getting off on a tangent here. But yeah, so Don, if you feel that was a good definition, good explanation, I'm happy we were able to answer it.
All right. Well, thank you, Wayne, for being here. I know you got to roll pretty soon. But I think this is a really great intro to your lab and to the folks that we have coming on in the next couple episodes. Is there anything else you want to add before you got to jump off here?
No, I just appreciate the opportunity. I thought this was fun, and I think I hope this is informative, and people find utility in what we talked about to understand more about what I do, but also what the USDA does and how the USDA and the land grant institution, especially with Kari and I, work together to achieve some of those goals. And I think we've done a good job illuminating that. So I appreciate it.
No problem. Thanks for being here, and you'll be here with your postdocs, and we can pick your brain some more then too.
Sounds good to me.
All right. Say goodbye, everybody.
See you later. Thanks.
See you later. Take care.